All right, picking up with number 10, it says to solve the following equation. Well, the first thing we need to do is clear the parentheses on the left side and then also combine like terms on the right side. So, whenever we go through and distribute, on the left side we need to distribute that 3 onto 3x plus 2. And on the right side, we need to combine the 11x and the minus 2x as well as the 3 and the 3. First, let's distribute. So 3 times 3x will give us 9x. 3 times 2 gives us a positive 6 equals. And then the 11x minus 2x gives us 9x. And then positive 3 plus another 3 is going to give us plus 6. Now you might notice these are exactly the same. 9x plus 6 equals 9x plus 6. That means that we have an identity. If you didn't recognize that these were the same and you want to continue solving for x, the next thing you would do is subtract 9x from both sides. And then both 9x's cancel and we get 6 equals 6. If all of your variables go away and you're left with a true statement, it's an identity, and all real numbers will work. So the correct answer for 10 is B, the set x such that x is a real number. For number 11, 5% of what number is 74? When figuring these out, if you think about percent over 100 equals is over of, well, we're talking about 5%, so put the 5 over 100, of what number is 74? Is, being 74 goes on top, and what of what number means we don't know, so we're going to put a variable down here. Whenever we cross multiply and divide, because we have a fraction equals a fraction or a proportion, then we're going to get 100 times 74, which is 7,400, equals x times 5, which is 5x, so we cross multiply and then divide. Divide both sides by 5, and 7,400 divided by 5 is going to give us 1,480 for x. For number 12, solve the formula for the specified variable. We have x equals bt, and it wants us to solve for b. So we need to get b alone. In order to do that, we need to get rid of this t. This is b times t, so to undo multiplication, we're going to divide both sides by t. They cancel out on the right side, and we're just left with x over t equals b. For 13, solve the inequality 16x plus 3 is greater than 4 onto 4x plus 1 minus x plus 4. Well, to do that, the first thing we want to do is clear our parentheses, and then we're going to combine like terms. So to clear the parentheses, we'll first distribute this 4. So we have, there we go, 16x plus 3 on the left is greater than, and whenever we distribute, 4 times 4x is 16x. 4 times 4 times 1 is 4, so plus 4, minus x plus 4. Combine like terms on the right side. So 16x minus x is 15x, and then plus 4 will be plus 8. I'm just going to carry that over since I ran out of room. So 16x plus 3 is greater than 15x plus 8. Whenever we move our variable, the 15x, over to the left side, we're going to subtract 15x from both sides. 16x minus 15x is x, plus 3 is greater than 8. And now we're going to move the 3 over to the right side, so minus 3. We get x is greater than 5. Because this is greater than and not greater than or equal, we know it will be an open circle. And also, whenever you solve in your variables on the left-hand side, whatever direction this sign points is the direction your line goes. So we know from those two facts that B is the correct answer. But if we think about it, x is greater than 5, Anything greater than 5 is going to include 6, 7, 8, 9, 10, and so on and so forth. So we can logically verify that that's our correct answer also. For number 14, the bar graph to the left shows the percentage of the U.S. population that was foreign-born for each decade of the 20th century. The percentage, P, of the U.S. population that was foreign-born X years after 1900 can be modeled by the formula P equals 0.0021x squared minus 0.286x plus 16.28. For A, according to the model, which the model is going to be the equation, what percentage of the U.S. population was foreign-born in the year 2000? Well, X is the number of years after 1900, so to solve A, we need to know that X is going to be 100, since the year 2000 is 100 years after the year 1900. So we'll have P equals 0.0021, and where your X's are, just put parentheses, and then we'll fill them in with the appropriate value, which is going to be 100. And whenever you plug this into your calculator, you're going to get 8.68. So that's 8.68%. And then our directions tell us to round to one decimal place. So our answer will be 8.7%. Okay, and then it asks, does the model underestimate or overestimate the actual number displayed on the graph? Well, if we go to the year 2000, which is right here, and we look, it shows 10.4. Well, our model only came up with 8.7%, which means it underestimated. And if we subtract the 8.7 from the 10.4, we'll find out that it underestimated by 1.7%. For B, if trends shown by the model continue, and again the model is the equation, in which year will 30% of the U.S. population be foreign-born? So we now, where our P was, we're going to substitute in 30 and then solve. So we'll start with 30 equals the 0.0021x squared minus 0.286x plus 16.28. We're going to move the 30 over because we want to have 0 on one side, so subtract 30 from both sides. And we are going to have, and run out of room, so I'm going to go right up here, 0 equals 0.0021x squared minus 0.286x minus, and I still ran out of room, 13.72. And you can use your calculator to solve this. If you have a Casio, if you go into mode, and then this is an equation, so number 5, and then this is in the form of number 3, ax squared plus bx plus c is 0, and then you can enter in the coefficients, so the numbers in front of the x squared, the x, and then the constant, and then whenever we hit equal, we're going to end up getting that x equals 173.78. So again, this is years after 1900, so we have to add that to 1900, but we also are going to want to go ahead and round up. The reason for rounding up is that we're past 173 years. We're into the 174th year. So we'll have our 1900 plus 174, which will give us the year 2074.